In problem number 4, with the application of the first fundamental theorem of calculus, f of x is equal to the integral of t squared with respect to t from x squared to x cubed, and we need to solve for the derivative of f of x. So here, using the first fundamental theorem of calculus, we have f uh, of x, or the first derivative of f of x, is equal to the derivative of the integral of t squared with respect to t from x squared to x cubed with respect to x. And since the upper and the lower limits are with variables, so we need to consider a constant between this interval. So we let a be an element of the interval or closed interval x squared x cubed. This is common. And with the use of the first property of definite integrals, this becomes, this is equal to d over, or the derivative of, we can split this integral into the integral of x squared a and our function t squared with respect to t plus the integral of t squared with respect to t from a to x cubed. So that's with the application of property number 1. And since we can distribute this, okay, so we have d, or the derivative of the function, okay, t squared with respect to t from x squared to a plus the derivative of this integral t squared with respect to t from a to x cubed. Since the second term is already in its proper notation, where the constant is at the lower limit and the variable x cubed, or the equation x cubed, is at the upper limit, so we don't need to change its notation, or the way we wrote it. Now, however, on the first term, we need to place the constant as a lower limit and the expression x squared as the upper limit. So using the first property of definite integral. So this becomes the derivative of the integral, okay? And since we're applying property number 1, we're going to negate it or multiply it by negative. So this becomes x squared and a, and just copy the function t squared dt plus the derivative of t squared with respect to t from a to x squared. So in this case, we are now ready to take the derivative of the two integrals. So let's now go to the next slide. So let's copy the problem. So that's equals to d over dx, the integral t squared dt from a to x squared, close, plus, I'm just copying the previous equation or portion of the solution. So that's the derivative of the integral t squared d with respect to t from a to x cubed. So now with the use of the first fundamental theorem of calculus, then we can now simplify this. This becomes negative, the derivative of the integral t squared dt from a to x squared So let's do it one at a time and copy. Oh, the derivative of t squared dt ax cubed. Okay, now here on the first term here, so let's say this is our a1, this is our a2. So in a1, we have a negative d over dx x squared a dt. Okay, I'm just copying. So this becomes, we let u of x is equal to x squared, right? And our du over dx is equal to 2x. So in this case, this becomes negative u sub x squared, right? Times the derivative of u of x. So in this case, let's substitute the value of u of x. So this becomes, the value of u of x is x squared. So x squared times the derivative of u of x is 2x. So this becomes negative x to the fourth times 2x. And this is equal to negative 2x fifth. This is for the a sub 1. And we need to solve for a sub 2. So for a sub 2, let's solve a sub 2 here. And a sub 2 is the derivative of dx t squared dt from a to x cubed, if I'm not mistaken, right? Okay. Now to solve this a sub 2, we let u sub x is equal to x cubed. Now, why do we need to let u sub x? Because the upper limit here is not a simple expression or equation, unlike x. So we need to uh, convert it into a function. So as we could easily identify the solution of the integral or the derivative of the integral. So in this case, the derivative of u is du over dx is equal to 3x squared. So in this case, this becomes uh, u of x squared times the derivative of u of x. So our u of x here is x cubed. So x cubed times square, or x cubed square, times the derivative of u of x is 3x squared. So let's simplify this. This becomes x raised to 6 times 3x squared. This becomes 3x raised to 8. This is our a sub 2. So since to we need to solve for the function f of x, okay, or we need to get the derivative of f of x. So we have the derivative of f of x is equal to a sub 1 plus a sub 2. Now our a sub 1, let's go back. Our a sub 1 is negative 2x raised to 5. So negative 2x raised to 5. And our a sub 2 is equal to 3x raised to 8. So this is now our derivative of f of x. Right. Okay,